Hi guys, let's do a quick run through of finding area under the curve. So first thing everybody saw, we talked about the difference between a normal and a standard normal distribution. A normal distribution, notice they look the same, but remember normal distribution is just whatever data you're looking at, raw data, right? The uh, standard normal distribution, remember, always has a mu value of 0 right in the middle, and our standard deviation is always equal to 1. So it kind of puts everything in the same context. We're not dealing with one class has a grade of whatever and another has a different average. So remember, when we're finding areas under curves, we can have things that are shaded to the left. So everything from the left, you might have a positive z-score or a negative z-score, and you can use that mean to help you out. Shaded to the right, remember our table only gives us left areas. So when you look up, you've got this area or this large area. What do you do in order to make sure that you've got the correct answer if I'm shaded to the right or greater than? 1 minus the area that you found. And between, remember, we go back to our basic math when we first learned subtraction. We know that the area here is all of this, and we want to take out that part. So we subtract. You always subtract and take the absolute value, subtract so you've got a positive area, because remember, probability can't be negative and area can't be negative. So a couple quick problems. I think we're good on this one. Let's do a negative 1.24 and it's shaded to the right. So remember, the best I can do is start by finding the area to the left. When I look that up on my z-table, a negative 1.2, and remember you go across to the 0.04, it looks like a 0.1075. So I know that, but I still don't know the yellow shaded area. So remember, we're going to do a 1 minus, and final answer comes out to something like a 0.8925 in that shaded area. Does it make sense to you that it's 89.25% of the curve? Yeah, right, because it's the larger portion. Everybody knows that 0, a z-score of 0, is what area? If I said find the area to the right of a z-score of 0, you would know what that was, right? So what about this guy? Between two values. So if I look up a z-score of 1.62, I've got a large area of something like 9474. That's from here all the way to the end. I want to take out this area, so I'm going to look up my z-score for a 1.35 because that's what has to come out. That looks something like a 0.0855. Did I say that right? 0.0885. I knew something was wrong. I want to take that away. Basic math tells 9474 minus the 0.0885. This could get tricky to do some quick subtracting. That's going to be like 98. Oh my goodness. I got to borrow all over. Make that an 8, make that a 13, make that a 16. So 9858. So that's 85.89% of my graph, or the area is 0.8589. What do you know the areas always add up to? And what do you know that probability always is? I threw a sneaky problem in here. You have to really be looking, thinking, and figuring things out. If I ask you to find the z-score on this problem, you know that the z-score has to be positive, right? Because it's to the right of the mean. So when we do between problems, we subtract, right? We subtract, we take out this whole area. We took this area and subtracted that other. Well, this whole area that we subtracted out has a z-score of 0. So I have to put that 5,000 back in there. So when I go, I'm going to have myself a 0.7123 is this whole area. So then here's the fun part. Jump into the table. Go into the table, find a 7, 1, 2, 3. I happen to know it's going to be on the positive side of the table because it's a positive z-score. When I find 7, 1, 2, 3, remember it's not always exact. This one happens to be. It looks like it's going to be a z-score of 0.56. So you jump into the table, work your way out to find the z-score. It's understanding what you're looking for. If my z-score was over here, instead of that positive, if it were a negative, then I'd have to subtract and figure out what I've got. So you really have to understand what you're doing. So quick run through of z-scores.